Morty, we've got to turn the project in early.
Hey everyone, I see Leah here, I see Tara here, and we'll do Tara's question coming up. The mayor question, null and alternative about the mayor. We'll do that here, but we see some Canvas content wrapping up the project, like that right there. So make sure, follow what we do in the videos. So, Canvas content. So follow what we do in the video. Blake, good to see you. Let's throw out some points. Blake got a ridiculous amount of points right there. I love it. Follow what we do in the videos. Lockley, good to see you here too. We're gonna do some Canvas content to start. So let me get the Canvas content loaded up right here. And then we'll do the null and alternative. Thank you so much, Tara, right there, mentioning nulls and alternatives. And we did all the questions yesterday, but we are still gonna do them. So I like to do it. I do the same thing if it's a different day generally. But check out yesterday's videos, or we're gonna do them today. We got a lot of time here. Let's do Canvas content because we haven't done that yet. That's a good place to start. So let's load that up. How's everyone doing? We only have, do classes end on Wednesday next week? When's the last day of classes? Let's see here. Is it Wednesday? I think it's Wednesday's the last day of class. So I said we had only 3 days. 4? Oh, I might have misspoke. Last day of classes is Wednesday next week. So we do have 3 more classes. Wow, that's a lot of time. We're so good on time. Not ready for class to be over? Ah, we got this. Is a half page good? Yeah, that's good, Jacob. That sounds really good for future research. If you said to the executive summary, that'd probably be good for executive summary too. Future research, make sure you just go into new ideas. Like, go beyond the project. Don't be talking about, oh, I found this and that. Like, don't be like, in the project, we found this and this and this and this and this. Future research is like beyond new things that you want to do. So it's not just about what you've already done. That would be the current project. So don't just talk about what you've already done. Good answers, Blake. You can always swing back by. You've seen it this semester that we have students who come by and say hey, and say, hey, Brian, how you doing? They say hey. But I love that. I love when students just swing back by. It's really meant to be a positive environment here. So I think there's too much negativity on the world. Solid copy. Don't reference the research. Exactly. Don't like, you can like be like, we found this in the report, but now we're going to go and do this. Now we're going to go and do these really cool things, or look into this like it's new ideas. So it's meant to go beyond. Okay, we got the Canvas content number 9 coming up. Got it pulled up right here. Keep asking those questions in the chat. We got one more question after this, but that's it. So here we go. Over to the Canvas content. Let's do it. Canvas content number 9. Stat 201. Canvas content number 9. Let me send out something to the 320 group and say office hours currently going on. Yes, 320. Office hours currently live. If you have questions about tonight's assignment, feel free to swing by and ask. There we go. Messaging 320. Okay, and let me go grab the link. Office hours currently live. There we go. And there we are. If I were to email you a project, I can give it a quick look over. I always give everything a quick look over, like a quick kind of glance through. So you can give me an email and I give a quick skim, and I've been doing a lot of them. So send it and I'll give a quick skim of the project. The sooner you send it, the better. Good question right there, Leah right there. Quick skim. I'll do like this. Hopefully I don't find much, but I'll do a quick skim. Here we are. You're welcome, Leah. A new diet is being tested. The inventor claims that you'll lose 10 pounds on average after 6 weeks. So that's their claim, that you will lose 10 pounds. 25 people are randomly picked to try a diet. Researchers are concerned that the inventor's claim is exaggerated. What is the correct set of hypotheses? So the null should have the what? The null should have the what? The null has the what? What does the null have? I want to check this one too, because I feel like it could go either way. The null should have the what? Whenever you have a null hypothesis, and let's go look at the notes, the null hypothesis always has the what sign. The null hypothesis written right here always has the what sign. The null always, 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 always has the what sign. What sign? We write HO, and then we put a parameter like P for the true proportion, then we put equals. Great job, Jackson. Locked linear right there. It has the equal sign. And then the researcher's question is what's going to determine the sign for the alternative. So the alternative is based on the researcher's question, but the null always has the equal sign. We need to pick the parameter of interest that we're testing, which in this is going to be the true mean amount of weight loss, which is a mu, and then the hypothesized value, which is mu naught. But for this problem, the hypothesized value is 10. So lots of good stuff in here. We could have mixed this up, and I wish it was just a written question, but we can't do that online. I think we're trying to see that you lose at least this weight. So should it be A, B, C, D, or E? We're trying to see if you lose at least this much weight. We're trying to see if there's evidence that their claim is true. Researchers are concerned that it's exaggerated. We'll double check. I could possibly get this one wrong because I think we're trying to check their claim to see if it's true. So I don't love the way this is worded. If this is on the test, I'm going to correct it. Because you could think of this two separate ways of what you're looking for evidence for. So which one do you think? I've done this question too. I'm second guessing myself. What do you think? A, B, C, or D, or E? Which one do you think? If we're looking for evidence the claim is true, so this is their claim. Okay, so that's the claim. I think that's going to clue us in on the right answer. A, B, C, D, or E. This is the claim that they're trying to say is true. So if they're trying to show that that claim is true and they're testing that claim and looking for evidence of that, which one of these should it be? Does anyone have a guess? Well, why? It can't be A. It can't be answer A. Why? So it can't be A because why? So it can't be answer A because the null has the equal sign. So it can't be answer A because the null doesn't have the equal sign. Does that make sense? So it can't be A. So it can't be A. It can't be the last answer right here. No, Jackson, Jacob right here. Let me throw 8,000 points, man. This is why I asked these questions. It's a good review. And then when you get to the test, you can eliminate some answers right here. And this is the practice. So I'm throwing you 10,000. Don't worry about it. Locknan, it could be D. Maybe people already know the answer is D. I think we're trying to figure out that you lose at least 10 pounds. That sounds like the claim to me, that you lose at least 10 pounds. It might be D. Do not submit this answer till we finish this. It's either C or D, depending on how we look at it. Is there evidence you'll lose at least 10 pounds, or is there evidence that you don't lose at least 10 pounds? I think the way it is with the claim being you lose 10 pounds, then we'd want to see you're losing at least 10 pounds. So we're looking for evidence of that. Or, I don't know. We'll find out here. Starting to rethink it. This one I absolutely love because this one is just a math problem right here. This is a straight math problem. So all we're doing is solving an equation right here. Do not input that last problem yet. Do not input it. Do not input it. Brian is saying maybe we want to go the other way on it. So with this problem right here, we need to first know our what. With this problem right here, we need to first know our what. With this problem, we need to first know our what. With this problem, it all boils down to knowing your what. Notation, brother.
Notation, brother.
Okay, identify any of these values. Identify any of those values. What are any of these values right here? Any values. N equals 25. Any other values? Because the test won't tell you what the values are. So you have to be very careful because a lot of people mix up values here. So what are any of the other values? S sample standard deviation is this. So what is the Y variable? Quantitative or categorical? Good job, Emma. Be careful. So P is proportion. Proportions must be between what? And P is true proportion. P hat is sample proportion. Jackson right there. Great job, Jackson. Mu. Well, but that won't be mu. Very close, Jackson. It's not the true mean. That's the mean from the what. So, hey, Adam, good to see you here. We're talking about former students swinging by. I love it. This is the sample average. So sample average is what? Sample average is what? So that's the sample average. So sample average is what in notation? I'll write the equation down here, which will help us out, but the test doesn't give you equations. The sample average is what? The sample average. The sample average. So it's not mu. Mu is very close because mu is population average. So mu is population average. So big hint right here. Have every notation written down. Write down what S is, sample standard deviation. Write down what N is, sample size. Close, Blake. We'll be using mu naught for a second. Adam is actually right. We usually call it the Y variable of interest. Great job, Adam, right there. It's going to be Y bar. So X, if it's an X variable, but this is the Y variable we want to understand. So bar right there means the mean of that variable. That's the mean of X. If this was an X variable, it would be X bar, but we are predicting it or trying to understand it. So we call it Y bar for the variable of interest. So now think about this up here. This is the hypothesized amount you'll lose. So what is this? And Blake, I think you're on the right track. What is the hypothesized amount you will lose? The claimed amount. Like the researcher says you should lose this. So that right there would be the hypothesized amount. Y hat is predicted Y. It's similar to that, but not quite very that close. Here, I'll write the equation. That would go here, Y bar minus. So it's not quite the alternative. So what is that right there? That is the claimed amount you will lose. That is the claimed amount you will lose. So that is the hypothesized or claimed amount you will lose. That is the claimed amount you will lose. They're saying you should lose this amount. That is the claimed amount you will lose. So what should that be in notation? Whenever you get a question mark, all the notation, and then you can find the formulas for it. So we're very close to solving everything. Oh no. What's that mean? It's mu naught. Great job, Emma, right there, and Blake. It's mu naught. So there's all the values right there. Now that we have it done, we can just input values. So Y bar is 4.2. That's how much we observed them losing. We expected them to lose 10. We take the difference. We divide by the standard deviation of the square root of n, which is going to be square root of 25. So that's negative 5.8 on the top. 7.1 over 5. And so that is equal to, it's going to be a negative t-score. And so 7.1 divided by 5 and 5.8 negative divided by that is negative 4.08. There we go right there. Does that make sense? That's the t-score. And then could anyone estimate? No worries, no worries. Oops. Could you estimate, and great job, Jacob right there. Good work. Let's throw Jacob some more points. Can anyone estimate the p-value for this? If you've been following along and doing the practice on this, you can draw this out on a t-curve with 24 degrees of freedom. And if we want to see less than, then we're going to go down here and go 1, 2, 3, 4. We're over here, and the p-value is going to be this because we're right here at 4.08 on a t with 24 degrees of freedom. So what do you think the p-value is about equal to on this? Could anyone estimate the p-value? It's going to be very close to what? Which the question doesn't ask, but you're way off the side of the curve. So the p-value is going to be very close to what? So here we are, 24 degrees of freedom, t-statistic of negative 4.08, and to the left, and the p-value is very close to what? The p-value is very close to what? So if you look at the visualization we drew, does that make sense to say there's basically no area over here on the side of the curve? So this is basically what we saw is virtually impossible given the null is true. So what should you do to the null hypothesis that you will lose 10 pounds? What should you do to the null hypothesis you will lose 10 pounds? You would say right here, I think we still have it open. You would say, I what the null. I what the null. we're looking for evidence you lose less than 10 pounds in this example. I reject the null. I know, right? Nice job, Adam, right there. I reject the null hypothesis that the weight lost on average is 10 pounds. I have evidence for the alternative with my p-value of 0.000, which is below the alpha of 0.05, that you lose less than 10 pounds. So the only thing this asked for was the t statistic right here, the negative 4.08. So we should be good, but we should also know how to finish the test, and that's good right there. So what is the t statistic? Negative 4.08, but did it have an extra decimal? That's it right there, to 2 decimals. If we construct a 95% confidence interval that does not contain the hypothesized value, which statement is true? Okay, so now we're constructing a 95% confidence interval. Should I add a negative sign? Oh, yes. Make sure to add a negative, Emma, right there. Add the negative. Do not forget that. That is very important. That means we were below the hypothesized value. So you have to add the negative because the t-score is negative because we are below the hypothesized value. So what we saw in our sample is below. If this were to be above, it would be a positive t-score. So the negative is very important, indicating our sample results were below what we expected them to be. We expected people, according to the null, to lose 10 pounds, but they were well below that. So we have a negative t-score. Very important. Thank you, Emma. Good question right there. The negative is very important, even for a 2-sample t, just for context of where did you land. Our sample results were below what we expected. So when we do a confidence interval right here, lots of things to understand. If I were to tell you the price of a steak dinner is somewhere between $30 to $50 at a really fancy restaurant, what is the margin of error of this interval? So here's the lower, and here's the upper. What is the margin of error of this interval? The margin of error of this interval, which we sometimes put questions like this on the test, is what? What is the margin of error of this interval? What is the margin of error? And the margin of error is known as what of an interval? What is the margin of error? Does anyone know? Good question. Is worth 1,000 points. What is the margin of error of this interval? It's 10. Great job, Jackson, right there. The margin of error is 10, which we would say plus 10 minus 10. What is the best estimate of the cost of the steak dinner? So what is the estimate of the cost of the steak dinner, which is the center of the interval? It's 40. Great job. It's the center of the interval right there, right? So that's the estimate, which is the center of the interval. So no, you got it. You're 100% right. Yeah. Can you re-express this interval as the center plus or minus the margin of error? Can you now try to re-express this interval as the center, which is the estimate, plus or minus the margin of error? Just try to rewrite the interval right now as the center. Like when I say 30 to 50, try to re-express it as the center plus or minus the margin of error. And then you'll see you've got it correct right here because you're like, oh, yeah, this steak dinner is about this plus or minus this. So think about how you would re-express the interval as the center plus or minus the margin of error. How would you re-express it? Just as a center plus or minus a margin of error, which the center is also the estimate of the best estimate of what it will cost. Center and estimate are synonymous words right here. So how would you re-express it? Instead of saying 30 to 50, which is the interval itself, so you could say the interval as 30 to 50, or you could say the interval what to what. So that's one way of saying it right there, or you could say the interval what. With the other wording right here, you could say what. How could you re-express it? 30 to 50 is the same thing as what? I'll give you the start of it. Not 30 plus. Good answer, Blake, right there. Not 30 plus or minus 50, because 30 plus or minus 50 would be equal to an interval that goes from negative 20 to 80. Yep. So you're seeing it, right? No, this is why I ask these questions. Once you do it a few times, it becomes like, oh, you're like, okay, wait a minute. And great job, Leo, right there. Yeah, once you see it, you're like, wait, 40 plus or minus 10. Does that make sense? So 40 plus or minus 10 is the same way as saying 30 to 50. So just seeing this stuff starts to make more sense. And the more you do it, you're like, okay, I get it. And I see where we're going with this. More points in the chat. So it's just the practice to when you see it, you start to get it. And when you look at an interval is created the following way. An interval, like a 95% confidence interval, covers the middle what percent of values. I know this is just the same thing, but a 95% confidence interval covers the middle what percent of values. A 95% confidence interval covers the middle what percent of values. I love the classmate collab level. The 95% confidence interval covers the middle 95% of values, right? So if someone were to walk up to you and say, I think a steak dinner costs $55, where is that value to your interval? The value of $55 is where to your interval? The value of $55 is where to your interval? You think a steak dinner with 95% confidence costs on average $30 to $50. 55 is where to your interval. And this would be a hypothesized average value of a steak dinner. So they are hypothesizing that right here. So that is their hypothesized mean. So where is that to your interval? It's where to your interval. It's where to your interval. 55 is where to your interval. Your interval goes from 30 to 50. 55 is where to your interval. 55 is where to your interval. It's outside your interval, right, Jackson? Jackson, good work right there. So would you believe that value or would you not believe that value? Would you say like, yeah, I think that's possible? Or would you be like, no, it doesn't seem likely? So when you're like, I did research on steak dinners in the area. It's probably between $30 to $50. And someone's like, well, I think it's 55. And you're like, I don't believe that. So you would what that value? You would what these values over here? You would reject those values. So anything outside your interval can be rejected. Now, if we make a 95% confidence interval, then what percent of the time are we rejecting? What percent of the time are we rejecting, i.e. the alpha level associated with this would be what? 5% of the time, it's actually 0.05 alpha right here because it's just the outside of the interval, 95% inside, 5% outside. And that is how this question is asking about it right here. So when we construct a 95% confidence interval, it's similar to a 5% alpha. That narrows it down to these two choices. And the interval does not contain the value. So if it does not contain the value, would you reject or not reject? So if it does not contain the value, which we see over here, it does not contain the value, would you reject or not reject? If it does not contain the value, would you reject or not reject? You would reject, and you reject at the 0.05 alpha level. So that's got it right there. A type 2 error, I absolutely love it. This is the end of class right here. So remember this. In a type 1 error, the what is what? This is just the easiest way to memorize it. Let's go to the main screen. In a type 1 error, the null, Blake, you're on the right track with that. So in a type 1 error, the null is what? We're always going to talk about the null. In a type 1 error, the null is true. If the null is true, it'd be an error to what it? So in a type 1 error, so that's a 1, the null is, and that's a T for true. And if the null is true, it'd be an error to what it? In a type 1 error, the null is true, and we reject it, which is an error. In a type 2 error, the null is what? In a type 2 error, the null is what? In a type 2 error, the null is false, and we what it? In a type 2 error, the null is false, and we what it? So think of the two F's. we fail to reject it. So it is false and we fail to reject it. So really quick way to memorize this. It is the null is false in a type 2 error and we fail to reject it. Because if the null is false, we should do what? Finish this sentence. If the null is false, we should do this. If the null hypothesis is false, it's like not true, we should what it? Hypothetically speaking, well, if the null is false, we should what it? So be careful, I'm asking in reverse right here. We should do what? If the null is false, like it's a false thing, we should what it? If the null is false, we should what it? So if the null hypothesis is a false thing, well, it's false. If it's false, we should what it? If I tell you something that's false, you should what that thing I tell you. If I tell you something false, hey, Meredith, good to see you. If I tell you something false, you should what that idea. So if I tell you something false, you should what that idea. I'm like, blah, 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 blah. And you're like, that's false. I what that idea. You should reject it, right? So think about why it's called a type 2 error. It's called a type 2 error because the null is false and we are making a what by failing to reject it. So the null is false and we are making a what by failing to reject it. Think about why it's called an error. Because if the null is false and we fail to reject it, we've made a what? Think about why it's called a type 2 error. If the null is false and we fail to reject it, we just made a what? It's in the statement of type 2 error. If the null is, we made an error, right? Does that make sense? Like, I want to connect the ideas more than memorization. Sometimes I go with like, the best thing to do is like memorize it and then understand why we say it. Like, the null is false and we fail to reject it is an error. So it's just the name of the error. Much sense, exactly. So it's like, wait a minute, if the null is false, we should reject it. And then the error is to not reject it, to fail to reject it. So kind of putting it in context, like what it means to make a type 2 error. So yeah, good stuff right there. So which of these, A, B, C, D? This is like, if you get this question on the test, you're like, free points, A, B, C, or D. A type 2 error. This is free points right here in my mind. If you memorize it, free points. But I also like to go for the deeper learning on these things. What is it, A, B, C, or D? Free points if you know what a type 2 error is. And you know my way with bait. Null is false and failed to reject it. There you go. B. Free points. When we reject the null and the null is true, we made a what? How many possible answers are to this question? How many possible answers are to this question? How many errors do we have? Oh god, I look over the test and sometimes you'll put type 3 error and I'm like, no. 50-50 shot, right? So can anyone, how easy is this if you memorize what I told you to memorize? Which one of these is it? Is it 1, 2, 3, or 4? How easy is it if you've memorized what I've asked you to memorize? It's the easiest, right? So which answer is it? People are like, it's the easiest. And they're like, oh, if I get it wrong, it's going to look bad, right? I wish 100% of students would get this right. It's type 1 error, yep. Because in a type 1 error, the null is true and we reject it. So if you get that down in a type 1 error, the null is true and we reject it. Definitely type 4. Blake, man, that's so close. I put that on the test. Unrelated, but my computer extension for SAT-1 project. Does my one sample ZET sidedness need to be related to the company I closed throughout? Kind of. Remember the sidedness is based on the box plus for the 2 cent. No, the sidedness I would say wouldn't matter. Emma, if you want to send it to me, let me take a look over it. Be careful for that first question. I'm a little worried about this one with the sidedness of it. Talk about sidedness of tests. Did I get it wrong? Frankly, I'd give you your points back if you got that one wrong. We did get it wrong. People must have known. It is the other one right there. It looks to be the correct answer is going to be this one that they're trying to show less than. If you did get this one wrong, please email me. I will fix it. But I think that's a little bit unfair because they're claiming you'll lose 10 pounds. So I was going by the claim. It's going to be this one right here. It's the only other possible one. I was a little worried about that one. Make sure that's not on the test. Let me fix this right now as we speak about this. I'm going to fix this right now as we're talking about this. 2 seconds, because I don't want other people to get hit by that question. I'm literally going to put in multiple right answers. I'm fixing the question. And then we'll do another version. Here it is right here. because the sidedness is just pretty confusing. And so this one right here. Wait, not going to allow multiple correct answers? Oh, come on. Usually you allow multiple correct. Okay, then let's do the following. Let's just delete one. That makes it a really easy question now. Because now, why is this so easy right here now? Who can explain why this question right here, with what I'm about to do to it and update the question bank, why is this question so easy right now? Why should this question be a complete gimme question to be like, yeah? And if you're in other classes, that's the right answer right there if you're doing this. Only one has the equal sign for the null. So it's just like, that's it right there. And Jacob, a good question. We'll probably do that next. The answer is yes. Lower p-values are more evidence. So we'll see if we get that on our next version of this. So let me update this question. If you're in another class, that is the answer. So if you don't get the updated question, which I've done right here, it's just the way you word things. What are you looking for evidence for? Are you looking for evidence that their claim is true, that you'll lose 10 pounds or more? Or like we were looking for more than 10 pounds. Like you're saying you lose 10 pounds. Let's see if you're losing more than 10 pounds. I guess we're trying to show evidence that you lose less than 10 pounds. It all depends on how you want to show evidence. That should be saved. I always try to see, is it saved? I think it's saved. I hit update question. Okay. At least we showed the answer, so the answer's out there. Okay, let's do another version of this, and then we'll do some other stuff here. Coffee break, grab some more coffee. Okay. Another version of Canvas content. Let's do it. Missing Evan. Where's Evan at? Oh my gosh, a researcher claims. What a complex question. What is your easiest way to narrow down the answers on this one? Oh my gosh, look at it. It's like it updated. The null has the what? Whenever you see something like this, you should always know the null has the what? 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 One thing you just got to put in the chat, the null has the equal sign. So no matter what you're doing, the null has the equal sign, and then the sign of the alternative is based on the sign of the claim, whatever they're trying to say. If it's not equal to the hypothesized value, if it's less than the hypothesized value, or if it's greater than the hypothesized value, one of these alternatives will be used based on the researcher's question. Now, since I know this question so well, the null has the equal sign, the researchers are trying to show that this diet is bogus. That's what they want to show. That's their evidence-based claim that the researchers are trying to show. Not the people who run the diet are trying to show anything. The researchers, from their perspective, are trying to show that you will not lose 10 pounds. So this is the evidence-based claim which they need to show evidence for. And there's only one option. If you have more than one option, make sure to pick the less than option. This one right here I do like. It's a calculation question. We might do it a little bit quickly. Once again, these questions right here, we did a previous one. So check the earlier version of this where I went more slowly. But this question really boils down to knowing your what. I'm going to do this one a lot quicker. Please check out the earlier version where I walk through and do every bit of notation on the problem. But I'm just going to show how this problem's a lot quicker if you know the notation. So the reason I'm able to solve this problem right here quickly is because we're testing weight loss. And weight loss is a quantitative variable seen by the average and by the standard deviation. That means we are testing the average weight loss against a hypothesized weight loss, which they're saying you will lose this much weight. And then to standardize it to turn into a t-statistic, we do the sample standard deviation over the square root of n, which is sample size. This gives us a t with n-1 degrees of freedom. The n-1 is subscript for the degrees of freedom for the shape of the t distribution. So please check out the earlier version if you want me to go a lot more slow on this one. It becomes a plug and chug problem where we need to put in the average amount of weight lost was this from the sample. The hypothesized was 10. They told us we would lose 10 pounds. Then we need to see if this is a large difference based on standardized units. So we take the standard deviation and divide it by the square root of n, which makes it smaller based on the size of the sample. And so this is equal to negative 1.6 over 6.9 divided by 5, because square root of 25 is 5. So make sure to solve and be very careful. There we go. Negative 1.6 divided by, there we go. So negative 1.16. Now it's good to draw these things out right here and think about how the p-value would look. Is our p-value going to be huge, medium, or tiny? What do you think the p-value will look like for this? Huge, medium, or tiny? I like to go above and beyond on these questions. Huge, medium, or tiny? So the null is that you will lose 10 pounds. The alternative is that you will lose less than 10 pounds. So is the p-value going to be huge, medium, or tiny? We have to plot the t-statistic on this curve and shade less than it. So is it going to be huge, medium, or tiny? What are your thoughts on it? We have to plot this on the curve with a t-curve with 24 degrees of freedom because the degrees of freedom are n minus 1. Huge, medium, or tiny? Take a guess at it, or an educated guess. So is it going to be, when you look at the p-value, is it going to be huge? Is it going to be tiny? Or is it going to be medium? What do you think? The size of the p-value visually on the curve will probably look about what? Like a ton of the curve shaded in, a little bit of the curve, or a moderate amount of the curve shaded in? A medium. Good job right there, Jackson. Because we're going to go right here to where the t is and plot this on the t curve right here. And that's where the t landed. And then we're going to shade to the left of it because the less than points to the left. And that's the t, or the p-value, excuse me. That's the p-value. So that is the probability of our results or results from our stream happening by random chance variation. So it seems like our result was slightly probable. So if 10 pounds is the truth, what we saw here seems possible. This is a p-value probably about 0.11, about 11% of the curve. Let's go take a look. Yeah, it's going to be a little bit more. It's going to be about 13%. We're going to find the exact value right here in a second. I'm going to guess 13%. Let's go bring up the t-curve, which this question doesn't ask for, but these are the last few steps to test it, and we just need to know how to do it. So 24 degrees of freedom, t-statistic right here, drop it in with a left-tailed test, and it is, wow, look at that. Within a hundredth of the decimal right there. There we go. So there's my drawing. And so if you compare my drawing to the actual answer, which is displayed over here on the screen, very similar drawing and very similar work. So the t-curve right there, and basically you would know above -1 is about 16% according to the normal curve, or below -1, I should say. The t is very similar to the normal. So if you were to put in here -1, you get about 16%. Lower degrees of freedom changes the t to a drastically different curve, though. So make sure you understand the t is like the normal, but it has larger tails with lower degrees of freedom, and it becomes more like the normal as you increase the degrees of freedom. Created by William Gossett by Guinness Beer. So we were only asked for this problem for the t-statistic, but we just did the full hypothesis test for it. So the t-statistic is all we needed right here. 2 decimals. When do we reject the null hypothesis? No answer text provided. When do we reject the null hypothesis? We reject the null hypothesis when the p-value is what? Very quick thing to say. When the p-value is this, reject the null. When the p-value is high, just let it fly. When the p-value is this, reject the null. When the p-value is high, just let it fly. When the p-value is this, reject the null. When the p-value is high, just let it fly. Below 0.05, and that means the p-value is what? So when the p-value is reject the null. When the p-value is low, reject the null. When the p-value is high, just let it fly. Just let the null fly. Just let it be. So a small p-value provides stronger evidence against the null. So think about this. When the p-value is lower, the null is what likely. When the p-value is lower, it means what the null is what likely. When the p-value is lower, it means the null hypothesis is what likely. Given, or our results are this, given the null is true. Our results were what, given the null is true. So we'd say the idea of the null being true is probably not true. Less likely. Our observed results were less likely given the null is true. So that'd be more evidence against the null. So the further away you land, I like to do like running examples. So think of your friend running around a track, and your friend says they can run a mile faster than 7 minutes. So your friend is claiming that they run their miles on average in faster than 7 minutes. So their average mile time is 7 minutes, and they want to show evidence that they are faster than 7 minutes on average. So the null would be here at the center, which is mu naught. If their sample mean is equal to, if they run a few miles here, let's say sample size of 7 miles. If they, or that's the same thing, 10 miles. on different days because it's going to wear them down. And they run their miles in 6.98. Where did you land? You landed very close to the what here. If they ran their sample miles in 6.98, you landed very close to the what? If they ran their miles in 6.98, they landed very close to the what? If you run your miles in 6.98 minutes, which is basically like 6 minutes, 59 seconds, you landed very close to the what? You landed very, very close to the what? You landed very close to the what? Hey, Ethan, good to see you here. Good to see you, Ethan. What did you land very close to right here? If you ran your miles, this is the observed result. So you ran your miles in 6.98. Your friend says, I think you're a 7-minute mile runner. And you say, I think I'm faster than that. He says, okay, let's see if you're faster than 7-minute miles. And you say, well, I ran them in 6.98 minutes. And they say, what would they say? You landed very close to the what? You landed very close to the null. So the p-value would be very what here? What we observed, given the null is true, is very what now? So what we observed, given the null is true, is very likely. So what would you do? Large p-value, right? So would you believe your friend is faster than 7 minutes or still believe your friend is a 7-minute mile runner? Like, would your friend have convinced you that they're faster than 7 minutes at this point? Would your friend have convinced you that they're faster than 7 minutes? They said, well, I ran my miles in 6.98 minutes. You would, and so be like, well, you're like, oh, that's, be like, that's kind of what? I think, Jacob, you're on the right track. So what would you say to them? You'd be like, well, I mean, if you're a 7-minute mile runner, then what you did right here is very likely, given you are a 7-minute mile runner, this is not strong enough evidence to convince me you're faster than 7 minutes. Does that make sense? Like, I need better evidence to believe you're faster than 7 minutes. Like, I mean, this just seems like what someone who runs 7-minute miles would do. Like, you're very close to that time. Does that make sense? Like, they would say, but I'm faster than it. And you say, well, but I mean, like, 7-minute mile runner means you're running in about 7 minutes. And what you did was about 7 minutes. That's very close to it. But they're like, but I'm faster. And you're like, but this isn't convincing enough to make me believe you're faster than 7 minutes on average. But what if they were to be down here on the curve? And that would mean the p-value is smaller. And they probably ran it closer to 6 minutes. So now they're running it right around 6 minutes. And so they run their miles here in 5.98 minutes. And you would say, okay, this is convincing evidence at this point. Your observed result in your sample, you're running it close to 6 minutes, even faster than 6 minutes. I have convincing evidence to reject the null and believe that you run your miles faster than 7 minutes. So at this point, the p-value would be even smaller because if they are a 7-minute mile runner on average, it's very unlikely that they would run their miles in this time. So this would be convincing evidence with a smaller p-value. So a smaller p-value is stronger evidence against the null hypothesis because what we saw was less likely given the null is true. Because they say, well, it's very unlikely you'd run your miles this fast if you are a 7-minute mile runner because 5.98 is just something a 7-minute mile runner shouldn't be running. Well, but we could test it because imagine they just bust out 1 mile and they just totally, tire themselves out. And you're like, I don't think you usually run your miles in that. I think that was a aberration. Let's have you do this. They're like, oh, I run every week and I run my miles in about 7 minutes. Say, okay, well, let's do this over 10 days. Because if you're just going to run 1 mile and just totally PR on that mile, that's a little different than, like how fast when you go to the track and you're running your miles around the track. We'll go 10 days and we'll see your average. We'll see how you do. Because if you use too much energy on one day, it's going to really come back the next day. So let's see if you are on average doing 7-minute miles around the track. So we'll do it over 10 days to get some variation. Low p-values are evidence of a true or false right here. This should be an easy question. Cause and effect are words we don't use in this class because we would only know this via experimentation. So low p-values are evidence of cause and effect, 100% false. When we reject the null and the null is true, we've made a what error? Very easy question right here, and then we'll do some other stuff, unless people want to do this one more time. But there was a question about nulls and alternatives next. When we reject the null and the null is true, we've made a what? And so in a type 1 error, we reject the true null. And this is a type 1 error. Should have 100 this time. Save it. Oh, save. It should be 100. I don't know if it shows 10 out of 10. Any other questions about this? I think everyone should have it now. Get those 10 out of 10s right here. So we need to get the new standard deviation. 6.8 divided by 5. 3.3 negative divide by smaller p-value is stronger evidence. 0.05 does not contain. We can reject 0.05 level. Reject null, null, true. Some equals. There we go. Get the practice. Get it down. There we just did it in seconds right there. We speed ran it. And so the more you get job, Leah right there, maybe some 10 out of 10s. But the more practice you get, the better. Understanding the equations. Obviously, I've memorized the questions at this point. But just practice and understand what they mean conceptually. Because the conceptual part of it is really what you want to understand. You don't want to just understand how to solve it. You want to understand the concepts behind it, which is why I don't usually solve them so quick to start. I usually go through and solve for p-values and stuff and show the notation. So each time I try to do it a little bit differently to hopefully help people understand what they're doing. I think people are wondering about the nulls and alternatives. Let's go check that out. Okay. Nulls and alternatives. Let's go grab it. I think it's like a dictator or a mayor. If you have questions, let us know. Okay. Quiz. Really good practice. That's basically like 2 chapters right there of knowledge that we're going over. Really good practice. Put any questions in the chat. We got only one more. All right, here we go. President about the negatives. I think this one is it. Okay. Here we go. Let's do it. Okay, so remember we did this whole quiz yesterday, but let's do a little bit of it now. A president is concerned about his negatives. So whether or not somebody likes the president, is that categorical or quantitative? Like when someone says, do you like the president? Is that categorical or quantitative? So cat or quant? Is that categorical or quantitative when someone says, do you like the president? It's categorical, which is why for this, we are putting in P right here. The parameter of interest is P, the proportion of people who either like or don't like the president. And you'll need to determine the first thing you're talking about is the parameter, and then the null has the equal sign. So we're lucky on this because we can always just put the equal sign for any of these. So there's the answer to all of them with the equal sign. And then the sign of the alternative is based on the what? So the sign of the alternative is based on the what? How do we figure out how to do the alternative sign? Because there's 3 different alternative signs. And how do we know which alternative sign to use? How would we pick between does not equals, less than, or greater than? Ayo, what's up, Justin? How would we pick between these? How do we pick between which one to do? The less than, the greater than, or the does not equals? How do we pick between those? Based on the context of the question, Justin, 1,000 points. We haven't thrown out some points lately, so let's make sure to throw out those points. Going to type it in right here real quick. points, add, plus, viewers, 1,000 points. So the sign of the alternative is based on the context of the question, what the researcher's asking, not based on the data. No, not based on the data. It's from the researcher's question right there. So let's take a look at it. They are asking, they want to keep their negatives below 80%. So if their campaign is successful, they will be able to show evidence what? The alternative they want to show evidence for, that's how that would be read. I want to show evidence for the alternative that the true proportion of negatives is what to 80%. I want to show evidence for the alternative that the true proportion of negatives is what to 80%. So they run this ad campaign to help them out because they're very unpopular. So we're saying after this ad campaign, we'll be able to show you evidence that your true proportion of negatives is what to 80%. After the ad campaign, we will be able to show you evidence that the true proportion of negatives is what to 80%. So don't even look at their answers. Yeah, do it, Justin. You got it. After the ad campaign, we want to show you evidence that the true proportion of your negatives is what to 80%. Less than. Now, this one right here is a four-sided dice fair. Yep, Justin, great work right there. Justin, thank you so much. Is a four-sided dice fair. If a four-sided dice is fair, then the probability of any side is 1/4. But if it's not fair, then the probability of one side would what? If it's fair, then there should be a 1/4 probability of a particular side. But if it's not fair, then the probability of that side would not be 1/4. So this one does not give a sidedness to the test. Don't worry about the side there. It's just saying, well, if the dice is fair, then you should see it about 1/4 of the time. If the dice is not fair, then you shouldn't see it about 1/4 of the time. Only about 21% of people who stop using drugs succeed. Sellers of a motivational tape claim that listening to their recorded messages can help people succeed. Let P be the proportion of people who stop using drugs and succeed. So if the motivational tape doesn't help, then it should remain about the same. But if the motivational tape helps, then the proportion of people who stop using drugs should be what to 21%? The proportion of people who stop using drugs should be what to 21%? The proportion of people who stop using drugs should be what to 21%? It should be greater than. That's what they want to show evidence of. Above. Great job, Blake, right there. Blake, what else are you wondering about? We've done this full quiz yesterday. Maybe we should do some chapter 16 or something, right? Should we do chapter 16? What do you think? Chapter 16? Chapter 16 homework? That's a new one we haven't done yet, and it's coming up this week, so maybe that'd be good, right? Chapter 16 homework? Maybe. I'll go bring up some chapter 16 homework. We could do the whole homework. Just get it done. Chapter 16 homework. Okay. Oof, tricky stuff right here. Wrapping up the project. Good stuff right there. If you have questions, let me know. Let me put some chapter 16 homework in here. And so 54, fall to 3, step to 1. Question 1. Okay. So this is about type 1, type 2 error, it looks like. Oh, interesting stuff. Which of the following is true? A p-value of 0.01 means that the null hypothesis is false. No, we don't know the null is false. Whether a p-value false, whether a p-value provides evidence against the null depends on the alpha level. So we'd have evidence to reject the null. So we could use an alpha level of 0.00001, and the alpha level is the point at which you reject the null. So that one, this one. So the p-value provides evidence against the null hypothesis, but does not show it's false. So both of these, both of these are kind of accurate. You gotta watch out right here. This p-value proves the null is true. No. That's just horrible. This p-value provides evidence against the null, but does not show it is false. Whether a p-value provides evidence against the null hypothesis depends on the alpha level. No, it provides evidence, but whether we reject. So the wording here is a little confusing because both of these are somewhat accurate. Whether a p-value provides evidence, it can provide evidence, but whether we reject depends on the alpha level. And they're just saying evidence. So the p-value provides evidence against the null hypothesis, but does not show it as false. So, because we could make an error. I think that's what they're getting at. Yeah. Because we can't say we know the null is false. We just have evidence. It doesn't show it's false. That was the first red flag to me right there. The alpha level is used to reject or not reject. So the p-value is providing evidence. Whether we reject or not reject is based on the alpha level. So alpha level is just reject or not reject. I don't know if we have any. We should have graphics open showing this, that where I could just redraw it if I really wanted to. But the alpha level is where we reject or do not reject. Here it is right there. I just saw it. When your p-value is below your alpha, you will reject. When your p-value is above alpha, at or above alpha, you fail to reject. Alpha is usually assumed to be 0.05. So if you go down here to the results, will you reject or fail to reject right here, Blake? Using the 0.05 alpha, so an alpha of 0.05 and p-values are probabilities, will you reject or fail to reject? You will fail to reject. So fail to reject because that p-value is above. The lower the p-value, the more evidence. Let it fly. Just let that null be. Do not reject that null hypothesis. Check out yesterday's office hours where we did this. So we would keep the null hypothesis and don't write these out in statistical notation for your project. But we talked about the project yesterday, and we would fail to reject this null right here. We do not have evidence for the alternative because the p-value is higher than alpha. So this depends on alpha is the reject, not reject. And the p-value provides more evidence the lower it is, but it does not show the null is false because we can always make an error. A p-value of 0.01 means that the null hypothesis has a 0.01 chance of being true. No, it means our observed results. This is a lot to take in, but let's show it visually. We were drawing this out here earlier. So this is your friend running a mile. If the p-value is this, what this means in context, I'm going to say the definition, and then I'm going to put it in context. The p-value is the probability of our results or results more extreme happening by random chance variation given that the null is true. So the probability of my friend running a 5.98 minute mile on average, my results, or something more extreme, i.e. we shaded this way, happening by random chance variation given that they are a 7-minute mile runner would happen about 1 in 1,000 times. So this observed result here is very unlikely given the null is true. That's not where the observed result is, but the observed result's over here. What I observed was very unlikely given the null is true. So it's a contingent probability. That's what the p-value tells us, is the probability of seeing what we saw given the null is true. What I saw was very unlikely given the null is true, so I'm going to reject the null hypothesis. So this sounds very false to me. The p-value is not the probability the null hypothesis is true. That's a quick way of saying it. No, it proves, oh gosh, just proves in there, tells you those are wrong answers. I wish they went into more detail. The p-value is not the probability the null is true. It's the probability of your observed results given the null is true. So for a question that asks if we reject or fail to reject, does that not give us the alpha level? We assume 0.05. Exactly. If it does not state alpha level, you assume 0.05 unless otherwise stated. A p-value of 0.01 is evidence against the null hypothesis. That sounds about true right there. Provides, they could say enough evidence to reject the null, but I think this right here is evidence against the null hypothesis. Provides evidence for, no, we wouldn't provide evidence for. It's either going to be A or B, but whether or not you reject and what they're getting in here at the end, yeah, they're going to go towards that. Okay, so a p-value of 0.01 means we should definitely reject the null hypothesis. False, whether you reject depends on the what. Whether you reject or not reject the null depends on your what. Whether you reject or not reject depends on your what. Whether you reject or not reject depends on your what. Whether you reject or not reject depends 100% on your what. To reject or not reject depends completely on your what here. Because I could say alpha level. So Blake, here's your p-value right here. Be very careful. Do you reject or not reject? Do you reject or not reject? Be very careful with the p-value in the alpha level. Do you reject or not reject? Reject or not reject? This is a tricky question, but remember how it works. The alpha level is the bar by which you have to go under to reject. So if the alpha level is stated, you have to use that alpha level to say we have to reject p-values below this. So on this problem right here, is your p-value above alpha, at or above, or is it below alpha? And I've visually done it here. Where is your p-value? It's above, so what do? This is a weird one. It's like one of those ones that you have to be like, wait a minute. So with this, you would fail to reject or not reject. Same wording right there. And so you're saying you need ridiculous amounts of evidence. So with this right here, you're like, I need tons of evidence to reject the null. So you would say I need a lot of evidence. So it really depends on the alpha level right there. Really good question going over stuff. So that is good theory right there. Very, very, very complex theory on the problem. Very exact wording. I wish they went into a little more detail on a few of those. But good theory. Okay, question 2. Using an alpha level of 0.05, a p-value of 0.03 results in rejecting the null hypothesis. True or false? Using an alpha level of 0.05, a p-value of 0.03 results in rejecting the null. True or false? True or false? Using an alpha level of 0.05, a p-value of 0.03 results in rejecting the null. How do you know to reject the null? When the p-value is what to alpha, you reject the null. So you have an alpha level of 0.05 and a p-value. Alpha. So what would you do right here? You would definitely reject the null. So this is as true as a statement gets because the p-value is below alpha. That is as true as it gets. So that's going to be good right there, and they explain a little bit more. The alpha level depends on the sample size. Have you ever, yes or no in the chat, have you ever heard me say anything about deciding the alpha level with the sample size? Or do I usually just say, here's my alpha level? Alpha level depends on sample size. Thoughts on that? Alpha level depends on sample size. No, I've just said, here's the alpha level. You just decide your alpha level, you pick it. The statement is false because the alpha level is set independently and does not depend on sample size. Yeah, it's just, you just say, here's my alpha level. You just pick it. What percent of the time do you want to reject the null? With an alpha level of 0.01, a p-value of 0.05 results in rejecting the null. So what do you notice right here? If your p-value is above alpha, what would you do? So don't even read their answers. With a p-value above alpha, what would you do? So don't even read their answers. Just be like, wait, if my alpha level is 0.01 and my p-value is 0.05, so it would look like we'd have an alpha level of 0.01 and p-value of 0.05. So what do we do here? So what would we do right here? What should be the choice? We should do what? So if your alpha level is 0.01, your p-value is 0.05, you should do what? Alpha is just the bar at which you reject or fail to reject. It's just you say, I need to go below this to reject. So with a 0.05 p-value and a 0.01 alpha, alpha is just the point at which you reject or not reject, you would say, I what? So what would you pick to do right here? Remember, alpha is just a bar you set to say, this is when I'm going to reject the null. You would definitely say, with this alpha level, I fail to reject the null. You'd be like, I can't reject. My p-value is too high. So looking right here, this statement is false because a p-value greater than alpha indicates that no, it doesn't indicate the null is true. This statement is false because only p-value less than alpha results in rejecting the null. That is true. No, we don't reject the alternative. So we only reject or fail to reject the null. And this is the last one right here, with an alpha level of 0.05 and a p-value of 0.06, this means the null is true. No, we don't say the null is true. It just means we didn't have enough evidence to reject it. This statement is false because p-value greater than alpha indicates the alternative is... No, we don't say that. This statement is false because p-value greater than alpha only indicates there is enough evidence. No, we don't accept the null either. This statement is false because a p-value greater than alpha only indicates that there is not enough evidence to reject the null. Exactly. We either reject the null because there is enough evidence, or we fail to reject the null because there's not enough evidence for the alternative. Let's do the next one. Good stuff. These are really good theory questions. Very, very complex understanding of the topics. We have time for a few more. And make sure to try to write these down and understand when we reject, know what alpha is. It is better to use an alpha of 0.05 than an alpha of 0.01. What? This is probably it right here. A lower alpha level lowers the probability of a type 1 error, yeah, because your alpha level is your type 1 error, but increases. It really, I mean, that's true, but it's, I don't know, it's situational. Yeah, I don't like the way this is worded. This is very situational. It just depends on what you want to do. Do you want to, you will increase your type 2 error rate, but you'll lower your type 1 error rate. A good thing to memorize right here is your type 1 error. I know, weird question, right? Your type 1 error is your alpha. Your type 2 error is your beta. Type 1 errors are considered a false positive. Type 2 errors are considered a false negative. And we'll go into that more in next class. But if you increase your alpha, you increase your type 1. But increasing alpha has the effect of decreasing beta, which would decrease type 2. So it is true if you, if you decrease your alpha, you're going to decrease your type 1 error rate. So a lower alpha lowers the probability of a type 1 error, but increases type 2. They are inversely related. So I think that's where they're going with this. It's just depends on, it should say depends on what the researcher wants at the end of this. It depends on what you want. That is a true statement. It's not better to use it. The alpha level should be set to the smallest value. No, you set it before doing any work. You don't pick it based on a p-value. If we use an alpha level of 0.01, then a p-value of 0.0001 is statistically significant. This should be an easy one right here. What do you think? An alpha level of 0.01 and a p-value of 0.001. We got to close down some Word documents here. So an alpha level would this p-value right here be statistically significant? Yes, 100%. Easy one. So with an alpha level of 0.01, a p-value 0.01, that is statistically significant. It means it's below the alpha level. If you use an alpha level of 0.01, then we reject the null hypothesis if the p-value is, I mean, same thing, yeah, because it's statistically significant. Then we reject the null hypothesis if the p-value is this. That is very true. That is true. If the p-value is 0.01, we reject the null hypothesis for any alpha. No, we wouldn't reject. Wait. If the p-value is 0.01, yes, that's true also, which is weird. You don't usually set the alpha level after. So they're saying if your alpha level is greater than that, you would reject the null. So any alpha level greater than this would reject. That is true also. I don't like the way they state that, because they're saying like if you had an alpha level greater than this, it's just basically saying with a alpha level greater than 0.01, p-values of 0.01 would be rejected. That's true. And once again, this all is reviewing the idea on one of our last documents right here, that when your p-value is below alpha, you reject. That's the big central idea of these questions here at the end. P-value below alpha, reject the null hypothesis. So lots and lots of review over that. And reviewing it again, what is the name of the threshold by which we reject? So just put it in the chat right here. What is the name of the threshold by which we reject the null hypothesis? So this is just the threshold by which we reject. What is that called? The threshold by which we reject the alpha level. Nice and easy right there. So that is the alpha level. Boom. Easy question. Easy stuff. Oh my gosh. Another easy one. If the p-value is smaller than the level of significance, what should we do? Another easy one. Like I said, this is an easier chapter. It'll be very quick next class. If the p-value is lower than the level of significance, what do? We reject the null hypothesis. These are so quick, I can't even mark them. We reject the null hypothesis. Should be nice and easy right there. What is the probability that a test correctly rejects the null hypothesis? Ooh, now we're into some tricky stuff. So the probability a test correctly rejects the null hypothesis. So this one requires a little more explanation. The p-value is the probability of our results or results more extreme happening by random chance variation given the null is true. So the probability a test correctly rejects the null is going to be something a little bit different. So let's examine something we talked about just a second ago. And here we are. So this is basically going to be the lecture right here for a moment, because when we do tests, we can make errors. So in a type 1 error, the null is what? In a type 1 error, the null is what? In a type 1 error, the null is what? The null is true and we reject it. So that's when we say, we have results, false positive. Oops, we don't have results. So it's making an error. In a type 2 error, the null is false and we fail to reject it. So let's think about this. If the null is false and we fail to reject it, that means we did not find results when results exist. Type 2 errors, the null is false and we fail to reject it. So explain to me, this is the what of a type 2 error? This is the what? 1 minus beta, because if beta is the probability of making a type 2 error, so beta is type 2 error, 1, 2, A, B. Alpha is the probability of a type 1 error, beta is the probability of a type 2 error. 1 minus beta is the what of a type 2 error. 1 minus beta is the what of a type, the what? Think of a C word. We either to reject. So it's the complement. So failing to reject the false null is a type 2 error. Rejecting the false null is the complement. Because you either reject, or we could say, because this is not reject, so not reject, but fail to reject for type 2 error. So does that make sense, Blake, right there? So failing to reject the false null is a type 2 error. When you fail to reject the false null, that's a type 2 error. Fail to reject the false null, type 2 error. But when you reject the false null, that means you've done the right thing. And so this is called power. And power is often described as the probability of correctly rejecting the false null. So power is, and this is a good thing to memorize, power is the probability of correctly rejecting the false null. Because you will either fail to reject the false null, or you will correctly reject the false null. If the null is false, you should reject it. And power is the calculation 1 minus beta. Beta has a few more components that go into it. I had decision trees pulled up, but beta right here, 1 minus beta is power, and power is the probability we correctly reject the false null, 1 minus beta, and beta is the probability of a type 2 error right here. So beta is the type 2 error rate, and alpha is the type 1 error rate. Things for next lecture, this is probably the biggest parts of this chapter, is the type 1, type 2 error, with alpha being type 1 error, beta being type 2 error. And beta is influenced by 3 things, which are the effect size, the sample size, and the alpha level. So effect size, alpha level, and sample size. But please ask any questions you have. So this question is just a multiple choice, but I'd even memorize, I'd put it on a note card. The probability we correctly reject the false null is the power of a test. Probability we correctly reject the false null is the power of the test. There you go. Good question right there. What is the name for the difference between a null hypothesis and the true population parameter? So you haven't seen all of these yet. So the answer is one you haven't seen yet. I did just say it. Do you have any idea what the difference that we have right here is, Blake? Take a guess for some points, Blake, if you want. I'll talk about what this means here. What is your guess for the difference we observe? What is your guess for the difference? Guessing, what's your guess? So type 1 error is not alpha level. Yep, alpha level is when you reject the null. So alpha level is when you reject the null. Good, we can eliminate that. Alpha level is just a bar that which you reject the null by. It's also your type 1 error rate. So your type 1 error rate and alpha are the same thing, so that eliminates 2, right? Critical value is actually decided by your alpha. It's effect size. It actually is. Great job, Blake, right there. That is correct. The effect size is the actual distance there is. So when you think about effect size, I like to talk about if I were to play Let's play basketball right here. And if I were to play my brother in basketball, there's Brian Darren, or I were to play my friend LeBron in basketball, which of these has a bigger effect size? Just submitted. Nice job right there, Justin. If we have that the true amount of points scored in a game on average between Brian and Darren is equal to 0, which is the null hypothesis, and the true average amount of points scored in a game between Brian and LeBron is equal to 0, which of these has a bigger effect size? Because this is the null. Which of these do you think has a bigger effect size? Which of these do you think would be easier to reject the null for? So the null hypothesis is that Brian is the same as Darren. There's no difference in the average amount of points that Brian and Darren get in a game. And the null hypothesis between Brian and LeBron is that there is no difference between Brian and LeBron. So if you observe something, like an observed difference right here, we'll say difference right here between Brian and LeBron in a game to 21 was 21 points. I'm not good at basketball. And difference between Brian and Darren in a game, the observed difference, which is our best guess of the truth, is only 6 points. Darren was nice to me. LeBron was also nice, but he's just that good. So with this right here, which of these is a bigger kind of estimated effect size? The effect size is the actual true difference, which we can only estimate from samples. Which of these is a bigger effect size? So this is literally the effect size is the difference right here. The effect size is the difference. And just think about what it means to say effect size, the size of the effect. Is there a bigger effect size between Brian and Darren? And this is estimated technically, so the truth is where the effect size is. Which of these has a bigger effect size? There's the null and there's the estimated truth, which is our best guess. So this is an estimated effect size. So you'd say, it looks like there's a bigger effect size between Brian and LeBron. And think about the effect size. It's just how much better this person is. So which of these would it be easier to see who's better? It'd be easier to see who's better between Brian and LeBron because LeBron's that much better. Darren's better than me too. But the effect size is larger between Brian and LeBron, so we'd be easier able to reject the null. And that's one of the things that goes into rejecting the null is the effect size right here, which controls our ability to correctly reject the false null, which is the power of the test, noted right here on the effect size. The larger the effect size, the smaller the beta. The smaller the beta, the larger the power, because power is 1 minus beta. More on that next class for the test. For each of these, big question. We only got a little bit of time left. Okay, really like this question right here. It's type 1, type 2 error. We should be able to finish off the quiz right here. Going a little quick, but how's questions have you got them? Chapter 16, homework, question 8. Only 2 more questions. Let's do this. Okay. A bank wants to know if enrollment on their website is above 30% on a small sample of customers. The test is that the true proportion of enrollment is 30% versus the true proportion of enrollment for the alternative is greater than 30%. And reject the null hypothesis. They do this in tests. Later they find out it was actually 28%. Choose the correct answer below. So in this instance, what kind of error did they make? So Blake, type 1 or type 2? So think about what a type 1 error is. In a type 1 error, the null is true and we reject it. In a type 2 error, the null is false and we fail to reject it. So it should be pretty easy to eliminate what kind of error did they make. So in a type 1 error, right? Because they reject it right here. Boom, they rejected the null. That means type 1 error. So they made an error. They made the wrong choice. It's not greater than this. This was a mistake. So type 1 error are the only possible answers. They might have not made an error if they did it correctly, but they did make an error. The actual value is not greater than this, but they rejected the null. Yeah, the actual value is close to... Yeah, so that's going to be right there. Good. Got a little worried on that other wording. A student tests 100 students to determine whether online students on her campus prefer soda brand A or soda brand B and finds no evidence, so they failed to reject the null. For preference, brand A is not 0.5. Later, a marketing company tests all students, so they do a census, so they know the truth. And so this means they know the truth right here. So, and on campus and finds no difference. Okay. So she found no evidence of a difference, and the marketing company finds no evidence of a difference. Really love this question. What do you think? How could you sum this up? A student says, I did a sample and found that there was no difference between the students' preferences. A marketing company comes in, has all students do this for somehow, does a census and says, yeah, we find no difference also. What would you say? So she failed to reject the null. And then think about what the marketing company also did. This is a very good question. What do you think? She failed to reject the null, and then the people came in and tested everybody and also failed to reject the null. So what do you think? Be very careful. I do love the way they are wording these. I'm going to send out the announcement for classes here while people think that one over. She failed to reject the null, and then the marketing company came in and failed to reject the null. And they did a census. That's the key to the end of this. Is like they also did it. They did a census. They know the answer now. Class in 15 minutes. Okay. And sending announcement. There we go. They found the same thing, right? No error. Exactly. And the big thing is it's the second one did the census of the population. So that's the answer. So her estimate that there is no difference, like she believes there's no difference, is true. The student did not make an error. The actual value is this, which is not rejected. So she made the correct choice. Yeah, which class? 320, 474? We got class today? That's 470, 201, right, Justin? Yeah, if you're which I think you're 201. No 201 today. 201's tomorrow. A human resource analyst wants to know if applicants this year on average scored higher on their placement exam than 52.5 candidates of last year. She samples 50 recent tests and finds the average to be this. She fails to reject the null that the mean is 52.5. At the end of the year, they find that the candidates here had a mean of this, which is much higher. So that's the truth. So she failed to reject the false null. So that is a type 2 error because they actually found that it was higher from the census. So the analyst made a type 2 error. The actual value was this, which is greater than. So she made a type 2 error. She failed to reject the false null. A pharmaceutical company tests whether a drug lifts the headache relief from 25% achieved by the placebo. They failed to reject the null because the p-value was this. That's a very high p-value. Further testing shows that the drug actually relieves headaches in 38% of people. So once again, they failed to reject the false null, right? So let's see right here. The company made a type 2 error. The null hypothesis was not rejected, but it was false. The true relief rate was greater than this. Yes. That's weird how they asked that one. What type of error is made when a true null is rejected? Last question right here. What kind of error is made when the true null is rejected? What kind of error is made when the true null is rejected? Really good review right here. What kind of error is made when the true null is rejected? Easy peasy questions. And the way we test these... Wait, Blake. Gotta practice. You ready? Here we go. It's practice, right? Make sure. So here's what you gotta do, Blake. In a type 1 error, the null is what? Say the full thing right here, and then we'll finish off right here. In a type 1 error, the null is what? In a type 1 error, the null is what? In a type 1 error, the null is what? The null is true, and we what it, because this will be an error. In a type 1 error, the null is true, and we reject it. In a type 2 error, the null is false, and we fail to reject it. So those are the two F's of a type 2. So when we conclude right here, it is true, and we reject it, that is the type 1 error, and that is the quiz right there, or the homework. So we just completed the full homework right there. Good stuff. We guess we did that in about an hour-ish. But yeah, that was good stuff. No, we didn't, like 30, 40 minutes. 30 minutes. All questions explained. Good stuff. Well, we're going to end off here. Email me those questions. Let me know what you have. Until then, bye for now, everyone. Bye!